In the last video, we saw how we can pass arrays as an argument to a function that takes a formal parameter that's an entire array. So all you need to pass into the function is the array name. And we also saw that unlike Java arrays, C++ arrays don't have any indication really of how big they are. And so you can call it, it's just raw memory. This is how I would put it. And so therefore, the thing to do is to, whenever you set up a function that takes an array as a parameter, send the size of the array as well as a second parameter. And all you need to do is, all you need to have is a simple int type parameter that has the size. So of course the array can be any type, floats, doubles, and later on even objects, arrays of objects. We will do that later, not right now. So in this chapter we'll stick to simple types like ints, floats, doubles, characters, so on. Alright, so there's a nice example, very similar to the example that we looked at in the previous video, where both things were ints. The array was an array of ints, and also, of course, the size was passed in as an int parameter. So I'm hoping this is pretty straightforward. Of course, it is advisable to have a const int number of scores equals 5 first, and then declare the array as having size. The thing that goes in square brackets should be this constant. The book sort of doesn't follow that approach every time. And once you do that, once you have a constant number of scores, you only have to have it that 5 in one place, and if you need to change it once, everything is changed. If you do it like this, if you declare change the size of the array, well, then you have to change this as well. Maybe you might forget, and so it's better to have a constant. So you might ask, well, exactly what gets passed under the hood or behind the scenes? How does the C++ compiler really handle arrays as arguments? Does it really make a copy of the entire array and pass it sort of like an array by value into the function? Actually, no. So I'll give you the actual, what it actually does is only passes the address of the location of the first element of the array. That's all that's passed into a function. So the alternative is to actually make a complete copy of that array, pass that into the function, and then when the function is done, nothing is passed back. Well, that would make sense. You could do that, but then the bigger your array is, the slower your function will be, because you have to make a copy of that. And so that's not done when you pass an array as an argument. For the sake of efficiency, all that's really passed is a pointer, or we'll get to pointers later. But think of it as the memory location of the first element of the array. That's passed in. So there are other things that the compiler knows about arrays that are allocated in the stack. For example, the array base type, that is it an array of ints? That's probably known by the function as well, because when you declare the function, you have as a parameter what kind of thing the array is composed of. So is it an int array? The function knows that. That doesn't have to be passed in. I guess you could think of it that way. Also, when you have an array on the stack, you actually do know the size of the array. It's sort of not exactly visible to the programmer, but you can get at it. So arrays that are allocated on the stack, you sort of do have access to the size of the array, sort of like a.length in Java, but not exactly. It's not quite that simple. These two things are not passed in. When you pass an array as an argument to a function, only the first thing, that is the address in memory of the first element or the first indexed variable of the array. Okay, so one of the effects of that is that this looks very much like pass by reference. That is, you're passing the memory address of the array, the first location, and you can sort of deduce the location of all the other elements just by using array syntax, the square bracket stuff. So you can get access to all these elements of the array that's passed into a function, so that function can actually change the contents of memory and therefore change the array elements. And that's why we think of passing arrays as sort of like pass by reference. Very similar idea. Okay, so this should be pretty straightforward to Java programmers who have used arrays. You set up an array or set up two arrays, one with 5 int objects and the other with 10 ints, and you can pass either one of these arrays just by using the names, no square brackets necessary, and also pass in the correct size of the array. And of course, as before, it's probably better to have a const int for number of scores and number of times. Okay, so Java programmers probably are familiar with passing arrays. It's nicer in Java, just mainly because you don't have to worry about the length. In Java, when you pass an array, you just use the name, and then whatever function you're calling, it can access the length it can access the size of the array by using the dot length. Right, that's a final int that comes with every array. All right. So we said that passing an array as an argument to a function is like call by reference, and therefore in that function you could change the contents of the array. Well, what if you don't want a function to change the contents of array? Then you use the const parameter modifier. It works just like const parameters for regular functions. So passing an array is like pass by reference. Functions can modify the array. Sometimes you do want that to happen. For example, let's say you pass an array as a parameter, as an argument, and you want the function to sort the array in increasing order, whatever. In that instance, you don't want to make this a const. What you want to do is just pass it in as a regular array. Sometimes you do want to maybe just search in the array and not actually change the contents. If you want to protect the contents from modification, then definitely use the const modifier before the array parameter, and this is called a constant array parameter, and basically tells the compiler don't make any changes. And so if you try to write to that location, write to any location in that array inside the function, you get a compiler error if you use const. Okay. Functions that return arrays possible, definitely possible. It requires the use of pointers, and we haven't hit that yet. This will all be done later. About chapter 10, we will get to how we can return an array from a function. Okay, so it is possible. Just not going to look at it quite yet. All right, so then we look at programming with arrays. Some of these things you had to worry about in Java. Some of these things you didn't have to worry so much. So there's plenty of uses. You can use arrays as some temporary storage where you can maybe increase the number of elements of the array and maybe decrease it. And so those kinds of things are called partially filled arrays. So you might not have all of the elements of the array have valid data. You might the actual locations that are used might actually change as you call functions. So that's when you do that, you have to keep track, as we had to do in Java as well. And then we'll take a quick look at sorting and searching chances are you've seen this before in either Csis 235 or 162. Okay, so let's say we have a situation where it's difficult to know exactly how many elements we need in an array. So then what the most common approach to this situation is to declare an array to have maybe the largest possible size in a particular program. And then we have to keep track of the valid data, which elements in the array is valid. Let's say we delete something in the middle of the array, then we have to shift everything up. We've seen that kind of thing before in Java. So these are all things that are essentially the same as in Java, but you'll see that you can use this something like this, an int, that's the number used. And so if you pass in an array as a parameter to a function, that function couldn't change the number used, and so you would want this, any variable that's passed in that reflects the number of elements that are used in the array, you'd want that to be a call by reference. Okay, so that would be the one thing that's different, I guess, in Java. So there's a nice example. It's many pages. The one thing that I think I want to point out is that note this number used. This number used is passed used as a call by reference. Is used with pass by reference, so that if this fill array changes the number of elements that are being used in this array, it can change this input parameter, and then it also becomes an output parameter. So it's like sort of like returning the number used. Okay, so that's slightly different from Java. So this is a very nice long example, many functions, definitely something that you want to go through. Most of it is just like in Java, so I'm not going to really go over this in a whole lot of detail. I'm going to quickly switch over to global constants versus parameters. So you could have global constants like size, for example, size of an array. So in this previous example that we looked at, this is from the previous video, we looked at function. Right now Eclipse is being slow. So we had an array, and we said the size of the array is a constant size equals 3. Now we could have taken this, sorry about that, we could have taken this statement and put it outside main, and everything works just like before. But now here's the thing. If you have a function called sum, it would be able to access this const int size equals 3, and therefore we may not have to pass this as a parameter if this function was declared later on in this same file. As long as it's in the same file, this function sum, if you had it set it up here, it would be able to see the size. We may not have to pass the size as a parameter, because all the functions in this file would be able to see this int size. So that's what is being discussed here. Constants, if you make it, you can make them global. That's not such a bad thing because they can't be changed. So it's a safe thing to do, basically. And these are declared above main. So functions that have scope to array size constant, therefore no need to send the size as a parameter. Then technically, yeah, but we should still send the size of the parameter as a parameter, size of the array as a parameter. So that previous slide is just debating if we have a const int over here, then we don't need the size here as well. In practice, actually, it's much better to have the size, because this function, as is shown here, it's actually I put it in a separate file, and therefore we have to have that size parameter.